Our elevator extra credit project was to measure one thing in an elevator, one accelerating up and the other accelerating down, and we had to create a theory behind while the object accelerating up's mass is different while the object accelerating down. And then we had to create a video on our theory behind it and why that happens and show all of our calculations and data of why this happens.
Our theory is that if the acceleration of the elevator is 0, the elevator is moving at a constant speed or it is at rest. The book pushes down on the scale with an equal force and the scale pushes back up with an opposite equal force. Going up, the inertia of the book would prefer to stay stationary to the elevator, and the scale must push up on the book with a greater force. This results in a greater normal force, which results in a greater reading on the scale. Going down, the acceleration is negative or it's downward, and the inertia of the book wants to stay at rest, but the floor of the elevator drops out a little. This causes contact force between the scale and the book to be less because less is needed to support the book's weight. Normal force is smaller, and the reading on the scale is then smaller and reads less than the true weight.
Our hypothesis is that when the elevator is accelerating upward, the reading on the scale will increase because of the greater normal force from the elevator floor and the reading of the scale.
Our other hypothesis is that while the elevator is accelerating downward, the reading on the scale will be much less because of the lower normal force given off by the scale and the floor of the elevator. And going down. Up.
Our lowest reading while moving down was 210 grams. Our highest reading going up was 272 grams. And our normal reading, which was at a constant speed, was 232 grams.
So to get each of these masses into its weight in newtons, we're going to take each of these numbers and we're going to times them by 9.8 and then divide them by 1,000. So this one is going to be 2.6656. 210 times 9.8 divided by 1,000 is going to be 2.058. These are all in newtons. 232 times 9.8 divided by 1,000, which is 2.2736 newtons. So to figure out the average acceleration for going up and for going down, we're going to use the equation force equals the mass times acceleration. So we're going to get the force from over here, and then we're going to use our mass, which is never changes. We're just going to use the normal mass, which is when we're moving at a constant speed. So, and we're also going to change that to kilograms. That's why it's 0.232. So first, to find the acceleration for going up, we're going to use 2.6656 newtons, and then divide that by the mass of 0.232. So that these cancel out, and then divided by 0.232. So then we get an acceleration of, let's see, but that is including, yep, and that's including the 9.8, so we're actually going to subtract 9.8 from this number to get our acceleration of just the elevator, which is minus 9.8, which is then 1.69 meters per second squared. All right, and then we're going to do going down now. So we're going to use the same equation, and this time we're going to use the force that we got for the lowest reading, which was 2.058 newtons, equal to the mass. We're just going to use the same mass again, 0.232 times acceleration, divide by 0.232 to cancel these out, and then, let's see, 0.058, and then divide that by 0.232. Oh wait, 2. which then gives us 8 point. So then we got the acceleration, which is 8.87. We still have to subtract 9.8 though, which is why that's gonna give us the negative acceleration because it's going down. So let's see. Then we get an acceleration of negative 0.93 meters per second. And those are gonna be our average accelerations for going up versus going down of just the elevator.
We concluded from our hypothesis that we were correct because as we were going up in the elevator, our weight increased and our average acceleration for going up was 1.69 meters per second. And our hypothesis for the elevator accelerating down was also correct because as we went down in the elevator, our newtons or weight decreased to a negative 0.93 meters per second.